Hello, 6th graders. Welcome to Big Ideas Math, 7th grade math, section 8.4, Areas of Composite Figures lesson. Pause while you write the lesson title and number in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can divide composite figures into familiar geometric shapes and use known area formulas to find the total area by completing Big Ideas math practice with 100% accuracy in multiple attempts. So we're going to start out using grid paper. So let's look at the area of the yellow figure. So here we go. If we follow our directions here that the book has given us, it says count the number of squares that lie entirely in the figure. So we're not worrying about the half squares yet. And when we do that, there are 45. So you can kind of count there are 4 up and down. Let me go get that centered again. There are 4 going up and down, and there are 6, 7, 8 going across, so 4 times 8 is 32, so there's 32 in that rectangular spot, and then there's 6 plus 4 is 10, plus 3 is 13 up here, so if you add those two, that's 45. So there are 45 squares that are totally in the figure, and then we need to figure out the number of half squares. So if you look at the number of half squares, there are 5. So there's 3 on this side and 2 on that side. So the area of a half square is 1 divided by 2, or 0.5, 1/2 of a square unit. So the area of 45 squares is 45 square units, 45 times 1. The area of 5 half squares is 5 times 1/2, which is 2.5 square units. So we would add that up, and that's 45 plus 2.5, which is 47.5 square units. That's a decimal point that I'm trying to make there. And then we'll do these quick on-your-own problems. We'll do these together. So this one, we're going to look at the area, and we'll do the same thing we did on the last one. There's 4 total squares here, and there's 3 going across in this rectangle, and 2, 4, 6 going down, and 3 times 6 is 18. So there's 18 in that little rectangle, and then we're not going to worry about the half ones right this second. We're going to worry about the ones that are totally within, or mostly within. So there's 1, 2, 3, 4, 5 going up and down here, and 4 is 9, 11, 12. So there's 12 total, or really close to total triangles here. And then if we just count these as halves, because some are really tiny and some are really big. So there's 1, 2, 3, 4, 5, 6, 7, and I counted this one as a full square, this third one down. So 7 times a half would be 3.5, so 3.5 plus 18 plus 12 is 30, plus 4 is 34, so 34 plus 3.5 is 37.5 square units. So that should be about where we are. And then if we look at number 2, again, ignore the half squares and we just look at the squares that are completely filled in. So in this top rectangle and bottom rectangle, they are 5 by 2, so that's 10 and 10. And then we'll count the total squares. So 4 on that first line, 3 on the second line. So that's 7 here. And if it's 7 on the top, it's going to be 7 on the bottom. And then let's look up top. There's 0 on the first row, 1 on the second row, 2 on the third row, and 3 on the fourth row. So that's 3 plus 2 is 5, plus 1 is 6 on the top, and that means there's 6 on the bottom. And then we need to worry about the half boxes. So there's 3 half boxes on the top and 3 half boxes on the bottom. 3 plus 3 is 6, and then we multiply that by a half, so that gives us 3. So we've got 3 plus all of these numbers that I scribbled in the box. So 6 plus 6 is 12, plus 20, plus 14, and when we add all of that mess up, we end up with 51, or we should, so let's see, or something really close to that. 26. Oh, we get 49. I was close. Oh, I see what we forgot. We forgot those 2 half triangles and those 2 half triangles. So that's another 2 squares, because it's 4 half triangles. 4 times a half is 2. So 49 plus 2 is 51. Mrs. Timms almost forgot those. Okay, so now we're going to do this when we don't have grid paper, which is the more lifelike situation. So we're going to find the area of the portion of the basketball court that is shown. The figure is made up of a rectangle and a semicircle, so you recognize that this is not an entire basketball court, this is just part of it. It's what we call the shooting lane. So the figure is made up of a rectangle and a semicircle, and we are going to find the area of each figure. So the area of the rectangle is 19 times 12, and that gives us the 228 down here. And then it looks like it's a circle, but this half of the circle is contained in the rectangle, so we don't want to count that twice. So we're just going to figure out the area of the semicircle here on the outside. So the area of the semicircle, we use our formula. Area equals pi r squared divided by 2, so 3.14 times 6, that's the radius. The diameter is 12, the radius is half of the diameter, so that's 6 feet squared. So 3.14 times 6 squared divided by 2. And when we do all of our calculations, that comes out to 56.52 square feet. So we add that up, and we get 284.52 square feet. Here's one more example where we're going to find the area of a figure, and we're given the measurements. Now, this one is nice because they've given you the lines to show you kind of how to divide things up. That is not always the case. Sometimes you're just given the figure with no lines in there. So you have to figure out on your own how to divide it up. But they were nice to you. So it says the figure is made up of a triangle, that's right here, and a rectangle, that's here, and a parallelogram, so that's right here. And find the area of each figure. So the area of a triangle, your formula, remember, is area equals 1/2 times base times height. So 11.2 times 4.5, and half of that is 25.2. And the area of the rectangle, 8 times 4.5, so area is length times width. so 8 times 4.5 is 36. And the area of the parallelogram, remember parallelograms are just like rectangles. They're just tilted a little bit. So area is base times height. And so it's 8 times 6.7, and that gives us 53.6. So the area of the entire figure is all of those added up together, which gives us 114.8 square centimeters. So let's do these on your own practice problems together. So we're going to split this into a rectangle and a triangle. So 9 times 7 is 63, so that's the area of the rectangle. And 6 times 9, so I'm moving that 9 down from the top to make it the base of the triangle. 6 times 9, so area of a triangle is 1/2 base times height. So 9 times 6 is 54, and half of 54 is 27. And we're going to add those two up, so that gives us 90. And it's 90 square meters. Now let's look at our little clover leaf over here. There's a square in the center, which it's a square, so we know it's 2 by 2, so that's 4 square feet. And then we have 4 little semicircles. So we can really figure these out as 2 circles because we can see that they're identical. So the area of a circle is area equals pi r squared. So we're going to do 3.14 times our radius, and the radius of our circle is 1. Oh, and we do not need to divide that by 2, but we do need to square it. So that just gives us a 1. So we really just need to remember that our radius is half of the diameter, and they're giving us the diameter of the circle. So the radius is 1, not 2 feet. So 3.14 times 1 squared, 1 times 1 is 1, so the area is 3.14, and that's the area of one circle, but we have 2 of those. So we have a circle here, and we have a circle here. So it's 3.14 times 2, which would be 6.28. And then we need to add that to our 4, and it would be about 10.28 square feet. And I hope yours looks much nicer than mine. And finally, just remember when you complete your 5th lesson, you need to just have your notes and your vocabulary and be ready to complete your Big Ideas math practice.